Continuing with our theme of looking at ways to encode things or use of binary. Okay, one thing that's historically a useful circuit was a 7 to 4 Hamming code encoder. All right, so in the early days of digital logic, when you tried to connect and communicate data communications between computers, for example, the lines were kind of noisy and you often got some bits flipped. I say often. It doesn't take very many bits to get flipped before things become unreliable. So we were looking for ways to encode some extra redundancy so that we could figure out if we had errors in the data streams that we were trying to send. Okay, so one of the famous circuits for this, and that one that shows up in a lot of digital logic textbooks, is a Hamming code encoder. And on the other side, I have the decoder to show what it does. Now, these days, this would be considered a very primitive error correction circuit. All right, we have some much more powerful codes that we can implement in hardware. But this shows the basics, and that's the reason it shows up in a basic digital logic course. All right, so the way this is going to work, let me choose some random data, press this button, you can play with this too. And what it does is it makes some information bits that we want to send. So let's say we want to send these 4 bits, 0, 0, 1, 1. So we put these in 0, 0, 1, 1. Here's this circuit that's going to calculate what's called parity bits. All right, so we're sending this XOR in the purple is a 1, it shows up in this bit. Okay, this XOR coming between these lines is a 0, and that shows up here. And finally, these 3 lines, exclusive OR to parity bit number 3. Okay, so remember, an exclusive OR is basically a 1 if there's an odd number of 1s, it's a 0 if there's an even number of 1s. Okay, so you can check that and make sure that it works. Now, the idea here is this is the thing that we transmit. All right, so what would happen if you had a bit error? So we click on something that shows an error, and we're glossing over the details. I haven't talked about the decoding circuit, but you can also build a decoding circuit that's sort of beyond the level of this text or this course. And it will calculate what's called the syndrome. When I say calculate, it's just the result of another circuit. Okay, and so if the syndrome is 110, that's binary 6. It says, oh, the error was at position 6. So if I count this over, 0, 1, 2, 3, 4, 5. So 5 bits over is position 6. Okay, so let's do that again. Let's choose some more random data. All right, we get the output. We flip any bit along here. Let's say we flip this one. Okay, it says there's an error in bit position 1. Okay, so it looks like this is, representing Hamming coding accurately, and hopefully you can see applications where this would be useful. What I want you to come away with is that there are binary codes for different applications, and it turns out there's just a whole ton of them, all right? And so some of the classic ones are the things we've talked about with the gray code and the Hamming code, and we'll also get to ASCII and Unicode.